put your hands together as we welcome Professor Paul Freemont, Head of Structural and Synthetic Biology at Imperial College London, to the stage.
Thank you, and I just want to remind people perhaps why we're here. We've got a big problem. This is my favorite slide that I normally show all the time. This is the Earth anomaly surface to temperature. The red line is last year, 2023, and you'll see that we're getting close to 2 degrees for some anomalies on the Earth's surface, and you'll see at the bottom the temperature that we started with before the Industrial Revolution. We have a very serious problem. 2030, 1.5 degrees is sort of projected. 2050, 2 degrees is projected unless we do something. So we don't really have decades. I heard conversations about, oh, we're going to, it's going to take years and decades. We don't have that time. It's the great thing about climate change. There's an endpoint, and the endpoint can be far or it can be near, but there is an endpoint, and the endpoint is literally the Earth just boils, basically. So as part of that background, I just wanted to talk to you a little bit about standards and metrics. We set out to do a large global project funded by Eric and Wendy Schmidt Foundation, and it was to address the need for identifying technical standards and metrics to promote innovation and market growth in the bioeconomy. We looked at the areas of interest, which was obviously engineering biology, synthetic biology, biotechnology more general, and tried to understand why there is a lack of standardization. We also wanted to identify any technical areas that could accelerate commercialization, and based on this, we wanted to do it regionally, and we also wanted to set the scene for thinking about, as a technology, as an industry, about standards and metrics. We held 3 workshops, one in the Americas, one in Europe, in Brussels, and one in Asia. And we had 125 participants, 30 different countries. We had 3 different workshop reports. And then we coalesced it into the final report. And that's what I'm going to talk to you about today. So why do we need standards? Efficiency in the innovation pipeline, safety, reliability, interoperability, business benefits, consumer confidence and choice are really basic reasons why you need standards. And what happens without them? I guess the simple answer is you have different levels of chaos. There are different types of standards that really accelerate the innovation pipeline in all major industries: food, railways, aerospace, technology, computational science, ICT as an industry, all have standards. And there are many types of standards needed, things like common understanding, common language, common practices, platforms, common parts, reference materials so people can measure things in the same place, and management systems. Standards are linked to measurement. So measurement metrology plays a key role in industry, both supporting scientific research, but also technological development, manufacturing processes, how do you measure things as you develop manufacturing, fair trade, and consumer protection. So measurement is crucial to standards. And of course, there are measurement standards, measurement methods, techniques, calibrations, measurement uncertainty, measurement quality assurance, all really important parts for any industry. Different types of standards. You can have technical standards, measurement standards, product standards. You can have documentary standards. You can have data standards. You can have laboratory accreditation type standards. So everything is there. What about biotechnology? Okay. So this is the International Standards Organization Technical Committee 276, which is the committee responsible for setting standards in biotechnology. Currently, there are 35 published ISO standards for this multi-billion-dollar industry, and that is half the number that is published for dental instruments. And we also have around 250 different standards for light bulb fittings. So we're in an industry, it's chaotic, there's no standards. It's extraordinary. We have a multi-billion-dollar biotechnology industry with no standards and no metrics, no agreed metrics. So one of the things the report threw up was some major areas, 6 major areas that we need to look at based on acceleration of the bioeconomy, based on commercialization. Data standards, both metadata, reference data, just data. Feeding into machine learning and AI algorithms, we need very well annotated data so that companies can share data, and also that data from academia can quickly move into translation pipelines. Metrology and metrics to quantify biological processes. So when we're doing a R&D development process in a company, you can actually quantify some of the processes to introduce reliability, robustness, reproducibility, really basic stuff. Scale up, scale out. There are no metrics or standards for how you scale up a process. And the reason there are no standards in biotechnology is that everything is trade secret. So all the companies out there who have scaled up products onto the market know how to scale up. They know what to measure. They know what standards they have internally. They know what calibration instruments they require. They know pretty much the pipeline, but it's a trade secret. It's a competitive advantage. So we have an industry that is based on trade secret and competitive advantage. A lexicon, when you go around the world, people still don't know really what we're talking about when we say biotechnology. We need to develop more transparent language so everyone knows what we're talking about. What does a bio-based product actually mean? We need to think about sustainability and assessment. This came out really strongly in Europe, but also quite strongly in Asia. In fact, Asia is slightly ahead of us in this. And also from a commercial perspective in the US, and we had a big talk today on LCA, but there is no agreed metrics or reference information that would allow you to standardize a life cycle analysis for a bio-based product, which seems extraordinary given that this whole industry is making products that are going to go onto the market, and yet we have no agreed mechanism yet of how to assess their sustainability, which seems just absolutely mental. So hopefully we will be looking into that in more detail, and certainly the European Commission are looking into that very seriously. Biomass feedstocks. When you go to Southeast Asia, it's a very rich biomass resource area. They're looking at biomass as the future commodity. So they're wanting to think about biomass standardization, biomass metrics, because there are going to be great ships of biomass being shipped around from Southeast Asia to countries that don't have biomass to power their biomanufacturing capabilities. So this is a really interesting area. In the US, they're very keen on standardizing the methods for biomass analysis. And in Europe, they're also keen on biomass measurements. Because biomass is a very broad area. It's very heterogeneous, unlike oil, which is also heterogeneous, by the way. But there are a whole series of metrics and measurements that allow you to assess each barrel of oil that goes into your chemical petrorefinement. We don't have that in biotechnology. Training, education, public engagement, regulatory clarity for biotech products, and biosafety and biosecurity came out as non-technical areas. I've been through these, and I'll just quickly, because of time, I will just show you. So these are some of the quotes that came out. Measurement capabilities and metrics that perform consistently across scales or can be translated between scales are needed to support the engineering biology process scale-up. All the big companies probably know how to do that, but all of the smaller companies there's no open voluntary standards, they don't know how to do that. And that is an interesting debate which we can have. Lexicon, common understanding, metrics, reproducibility, reliability, robustness, to assess and compare, market incentives, developed market incentives. We really need to understand benchmarking across and measurement. And then, of course, we need to think about feedstock. And I talked about the diverse biomass feedstocks around the world, and we need to come to some agreement about what is a standardized biomass feedstock. Organisms can be engineered to accept particular types of biomass, and it's a very key area for biomanufacturing. So the non-technical areas, I think the regulatory clarity came out really clear around the world. So regulators are struggling with new bio-based products, particularly in the alternative food space. They're trying to work out how, and the European Union is also having a significant problem in its European Standard Food Agency regulatory process. It's very long, it's very difficult. And so I think on other products come onto the market, new bio-based products, there's going to have to be regulatory clarity to help regulators understand what these products are, and how do we regulate them. And therefore, measurement and standards come into enormous play in that space. And the report's available. We launched it in May. We're in the process of dissemination. This is part of our dissemination process. So thank you for waiting before lunch. It's very difficult to follow a really cool fashion discussion into something so boring as standards and metrics. So I do appreciate your... the problem is, this is not boring, and this is essential. And I think I would like everyone to think about why there are no standards in biotechnology, which is the only industry I know of scale, which is completely cowboy land. It's just like, no one cares. And I think we really need to adjust that. So the whole new generation of people coming through the system, building out companies, are really interested in developing open voluntary standards, pretty much how ICT developed in the 1970s and 80s. And I think you'll see a surge of this happening around the world. there's the report. You can download it. We have a booth. We've got some copies if you want. I was very honored to lead an amazing task force, a global task force from the US. They're on here, EBRC, NIST, which is the National Institute of Standards and Technology in America, Matthew Chang, who actually is now director of the National Center for Synthetic Biology in Singapore, Elizabeth and Jane, both working at NIST, and then Cynthia working with EBRC, the Engineering Biology Research Consortium, which is the largest US non-for-profit consortium on engineering biology. And then Juliet Malley, who's with me here, who was the project and program manager. And I have done it within 10, 9, 8, so I've done it. All done. Thank you very much.